Good afternoon. This is Mr. Sadler coming to you live from the internet. Today is Monday. Check my watch. Monday, the 10th of November, 2014. Once again, to the supply teacher, thank you very much for the help today. For the students, please play along. If I call on you, please try and answer. I know this is a little difficult with me not being here, and I'm going to teach you a relatively tough concept. I'm told Mr. Kemp is in with you right now, so he'll definitely be able to help point you in the right direction for this. Today our lesson is on the special triangles. Okay, so this is the beginning of what is considered to be the tough part of trig. What we're doing here, I need you to logically be able to do. You will be asked to reproduce these, the two proofs that we're going to do today on your next test, or at least one of them. One of them will be on your next test, the next will be on the final exam as well. This will help you to do a lot of trig in your head, which will make your life a lot easier. So the first topic is going to be the proof of the 45, 45, 90 triangle. Okay, so the first question is going to be a 45, 45, 90 triangle is one with two angles of 45 degrees and one of 90. The first question is going to be, how can you get a 45 degree angle? And the simple way we're going to do this is we're going to take a square and cut it in half, which I'm going to do right now. Sorry, I'm just going to check one thing. Oh, we're good. We're good? Sorry about that. You didn't need to see that probably. That's okay. Take a square, cut in half. So what I'm going to do, whoops, using my paint program, is I'm going to make a square right like this. Okay, and I'm going to, since it's a square, I'm going to put all four sides to be the same. I'm going to copy this onto our main note in a second, and all lengths will be 1. How am I going to do this? So excuse me for a sec. I need text, there we go. I'm just going to put all four the sides to be 1. It's taking longer than it should. That's okay. So what I've made here was a square with all four sides to be 1. The reason I'm doing this, and I'm going to give me a second here. It's very difficult to do on a laptop. The reason I'm doing this is I'm going to make 4 right angles here, hopefully. Okay, so there's 1 right angle. There's 2 right angles. There's 3 right angles. Oops. And there's 4 right angles. Okay, great. Okay, so what I'm going to do then, in order to get a 45 degree angle, all I'm going to do is I'm just going to split this in half, hopefully. This is much easier to do as a pencil. Now, since both sides were the same length, when you split the angle in half, you'll be left with an exactly 45 degree triangle. So what I'm going to do, I'll do this in black, hopefully. What that's going to turn into is a beautiful right angle triangle, just like this. I'll put the right angle in here as well. Okay, so since it's the same triangle, I'm going to put in everything that I can here, which will be slow again. Okay, I'm going to put an X in there as well. What I'm doing here, hopefully, is my 2 angles for my triangle here are going to be 45 and 45. The 2 sides that we know are going to be 1 and 1, they have to be the same. And then the hypotenuse is going to be X. What I'm going to do before I move any further is I'm just going to copy this onto my main note. Probably doesn't matter to you, but it does to me. Copy that on there. So there we go. Then I'm going to solve for X. Whoops, what happened there? Then I'm going to solve for X. How do you solve for X? Well, the answer is Pythagorean Theorem. So you're going to say, in general, the Pythagorean theorem is a squared plus b squared equals c squared. In this case, the two short sides are both 1, so I'm going to have 1 squared plus 1 squared equals x squared. 1 squared equals 1. So 1 plus 1 is 2. So therefore x is going to equal, if I can find it here, the square root of 2. I'm looking for my symbol here. All right, now the correct answer is plus or minus root 2, but we'll assume a positive length now because we're dealing with whole numbers. So what that actually makes then is, I've just shown then, this is my 45, 45, 90 triangle. Okay, all I'm going to do is I'm going to just take this triangle and erase the x, hopefully. And I'm going to do this with my pencil. Excuse me for my rough printing. This is using a mouse. Oh, goodness. Let's erase that. That's supposed to be a square root sign. Mr. Kemp, if this is you in here, if it's not Mr. Kemp, I apologize, by the way. We'll call that square root 2. So I'm going to select that, move it back. This is my 45, 45 triangle. Okay, how this is useful to me, it's useful to me in a lot of ways. Number one, this tells me any triangle that has a 45-degree angle, the proportions are the opposite and the adjacent are going to be the same. Okay, so if you have something 10 meters high and 10 meters wide, the angle is going to be 45. All right. We can also use SOHCAHTOA to get 6 answers from here. First of all, I'm going to say that, I'm going to start with sine. I'm going to say sine of theta. Okay, I'm going to pick a person at random now to tell me what sine equals. Let's start at the back here. Today it's going to be, we'll go Colton. Colton, hope you're sitting at the back today. What does sine equal, please? Okay, good. Opposite over hypotenuse. Next we'll go Lily. Lily, what's the opposite side? If you pick, so that's not theta, we should probably call that 45. If you pick, this is your 45-degree angle, what's the opposite side to there? Okay, good, that equals 1. What is the hypotenuse then? 1 over root 2. Okay, so we've just shown that sine 45 is going to be 1 over root 2. Now, where this is going to help us, and how am I going to do this? I don't know if it's on one page. Maybe I can do this. Excuse me for a second here. Sorry. There we go. Okay, so what I just can show you here, whoops, if you go down a bit, we just learned that sine 45 is in the proportion 1 over root 2. Anytime you see a 45-degree angle or multiple, you're going to tell me 1 over root 2. You're not going to say 0.707 or whatever it happens to be. We'll do the same thing now for cosine. Oops, I'm going to move up a little bit so you can actually see. Okay, so we're going to say cos of 45. What does cos of 45 equal as far as SOHCAHTOA goes? Kylie, since I missed you there, what does cos equal? Okay, good, adjacent over hypotenuse. Going back to the triangle over here, if this is your theta, what's the adjacent side? Okay, 1, and your hypotenuse is root 2. And again, if you want to rationalize that to root 2 over 2, go ahead. All right, finally, we're going to do the same thing for tan. Okay, it's pretty obvious how we're doing here. So tan 45, what's tan going to equal, please? In English, I'm going to pick on Georgie. What does tan equal? Good, opposite over adjacent. The opposite side here is 1, and my adjacent is 1, so tan 45 is equal to 1. And then if you don't believe me, check your calculators. All right, finally what I'm going to do is I'm going to extend this a little bit. If you weren't here on Thursday, you won't know what I'm talking about, but hopefully you do. The inverse of sine, what's the reciprocal of sine, please? Thank you, that's correct. That's going to be cosecant. Cosecant 45 should hopefully be hypotenuse over opposite. So it's just going to equal root 2. Root 2 over 1, which is just root 2. Then we're going to do the same thing. The reciprocal of cosine is going to be secant, which is hypotenuse over adjacent, which also equals root 2. And finally, cotangent of 45 is adjacent over opposite, which just equals 1. Okay, so that is our 45, 45, 90 triangle. All right, if the teacher there needs to hit pause and give the class a chance to type it in, write it down, go ahead, please. The next proof is going to be the 30, 60, 90 triangle. Now this one's a little more fun, but it's the same idea. I'm going to go to my nice board here. I wish I could save that. Oh, look, there it is. Okay, the question is now for a 30, 60, 90 triangle. How can you get a 60-degree angle? Just think about it. Where in life have you ever seen a 60-degree angle before? Well, the answer is, I'm not sure if this is obvious or not, but normally someone at least gets it. Where you get it from is a certain triangle called an equilateral triangle. Now, the reason an equilateral triangle, oops, what happened there? Oh goodness, oh Mr. Sadler. An equilateral triangle, remember, is all sides the same and all angles the same. So an equilateral triangle is going to be 60, 60, 60. By the way, this is the same thing I'll be doing on the board, except it would be a lot smoother because I'll be using my hand instead of this. All right, so I have 3 60-degree angles. How do I get a 30-degree angle now from there? Very good, chop it in half. Okay, so I find my line tool. Oops. Just chop it right down the middle. Okay, what I have done now is made another right triangle. Oops. Make that black. Made a nice right triangle now with the proportions 30 and 60. And it goes to 30 because it was cut exactly in half from my 60-degree angle. And I'm also going to put my right angle right there. Now the side lengths are a little bit trickier here. This time I'm going to pick, oops, where's my text? I'm going to pick everything as 2 this time on my original triangle. Can someone please shout out why it makes sense to have everything as 2 while I'm doing this here? Okay, well the answer is, let me make 2 of those. The answer is, if you're going to cut something in half, you might as well keep a whole number here. So I'm going to keep that side as 2 because it's the same as here. The bottom side's going to be cut in half, so instead of being 2, it's going to be 1. I'll throw an X in there as well because that's going to be what we're left with. Okay, so there's a 1. There's an X. Okay. Now, just so the note's complete, I'm going to put this on my other board. Excuse me for the rough equilateral triangle, but I think you know what I mean. Okay, so there's my nice, so I'm going to say here, start with an equilateral triangle. And cut it in half. Okay, then we're going to use Pythagorean Theorem. To solve for x. This time instead though, our hypotenuse is going to be 2. So we're going to say 2 squared equals x squared plus 1 squared. All right, 2 squared is, of course, 4. X squared is just x squared, not just a 1. So 3 is equal to x squared. X is equal to the square root of 3. Do I have the square root sign here? I'll use that one. How's that? Is that okay? Square root of 3. Maybe I can copy that. Does that work? No, it didn't. Okay, so what I'm going to do, sorry, I should go back there. If you need me to pause it here for a sec, go ahead. What I'm going to do is I'm just going to replace then this x with a root 3. Okay, so here's my 3. And here's my square root sign, carefully drawn. Oh, goodness. It's supposed to say square root is what that's supposed to say. Okay, hopefully that's somewhat clear. This is our 30, 60, 90 triangle. There's lots of great information you can get from this one. Okay, in fact, there's double as much as you could in the last one. Okay, so here's my 30, 60, 90 triangle. I'm going to start with sine of 30 degrees. Okay, once again, sine is equal to opposite over hypotenuse. The difference is, though, this one, you have to depend on what angle you're using. For 30 degrees, sine of 30 is going to be opposite, which is 1, and hypotenuse is equal to. So we're left with 1/2. Then I'm going to say, whoops, oh. Do the same thing for cos and tan. Actually, probably what the teacher can do right now is you can hit pause and let the class try and fill in for sine, cos, and tan of 30 and sine, cos, and tan of 60. Because I'm just going to do these right now. I'll do these quickly. So cos of 30 is adjacent over hypotenuse, which is going to be root 3 over 2. Finally, tan of 30 equals opposite over adjacent, which equals 1 over root 3. Okay, going the same thing with 60 degrees. Sine of 60 is opposite over hypotenuse. Now this time, if you're doing this at home, opposite to 60 is now root 3. It's not going to be 1 instead. So now we're going to change this to root 3 over 2. Cos of, whoops. Cos of 60 is adjacent over hypotenuse, which equals 1/2. And finally, tan of 60 equals opposite adjacent, which is going to be root 3 over 1, or just root 3. Oh, I lost it there. What happened? Okay, so those are your special triangles. You will need to know those, okay? And my recommendation is some people are just able to memorize this and memorize this, all right? Sorry, I memorize that and memorize this. For myself, I find it easier, I always have, to just do the proofs. The proofs aren't that bad. This one's just take a square, cut it in half. For the 45, 45, 90. For the 30, 60, 90, start with an equilateral triangle, cut it in half, all right? There will be a quiz this year that doesn't allow you to have calculators on. Here we go, example, I'm just the bearer of good news today. Example 1, let's find my note here. All right, we're going to say determine the exact value. We're running out of time here. We're going to say sine 45 cos 45 plus tan 45 sine 60. Okay, so what you should be doing right now is you should either have the special triangles drawn on the side of your page right now to find out what sine of 45 is. Sine of 45 from your special triangle should equal 1 over root 2. Cos 45 should equal, as well, the same thing, 1 over root 2. Tan 45 should equal 1. And sine of 60 should equal root 3 over 2. Yeah, I know, I'm going through this like this is so easy and it's trivial. This isn't. This is one of the stumbling blocks of trig. This is where life starts to get difficult. So what I'd probably recommend for you guys tonight, like if there's one thing you get out of tonight, I'll give you homework and all that to do. But if you're able to reproduce those 30, 60, 90, and 45, 45, 90 triangles with ease, so you can use them for other things, that's sort of the goal for that. Simplifying out, 1 over root 2 times 1 over root 2 is just the same as 1/2. Plus root 3 over 2. Which equals, with the common denominator, 1 plus root 3 over 2. All right, I think I'm actually going to stop there. I think this video is probably starting to get sort of long. I'm going to give you your homework right now, which is 287, number 4, 9, 11, 12, 13. I will go through some of this stuff tomorrow again to make sure this is all clear. I'll do a few more word problems and things like that that are a little bit more deep questions. Try the questions here tonight, see what you can do. I can go through the homework solutions. Probably some of the first half of tomorrow's lesson is I'll go through the trickier questions if they're difficult for you guys. Yeah, and that's that. So I have attached, and if the supply teacher, whoever's in there today, on the mrsadler.net webpage, there will be a copy of this page from the homework, so the class can get it and do it, right? So for those who didn't bring the books. All right, thanks everybody. Hopefully that went somewhat smoothly. See you later.